Hi, this episode we will talk about the definitions of the continuities. So we would like to find that our functions f is continuous or not, right? At the point x equals a, right? We have to check if and only if, right? We have to check three conditions, right? First, we check that the value of this point at this function exists or not, right? The second, we check that the limit when x close to a exists or not, right? And then the third condition, right? That means that the value from the first and the second conditions are equal. Okay, so this is the definitions of the continuous. Then let's see the examples, right? Okay, so on page 19 we have the function state that gx equals x squared minus 2. Check whether it's continuous at x equals 2 or not. Okay, so A. So first we have to find, right, the first condition, right? The value of the function as its point exists or not, right? So which is the real number, right? So this is the exists. The second condition, right? We check whether the limit of this function when x approaches 2 is exists or not. Okay, so we replace the gx is the functions of the polynomial x squared minus 2. Okay, so you got 2, right? This is also exists. And the third condition, right? The value of the limit is equals 2, which equals the value of the 3. Then we can conclude that, right? So G is continuous, right, at x equals 2. Okay. And if we expand, right, the condition to our examples, right? For examples, we have f(x) equals absolute x. Okay. At we find, right, if at the point a equals 0, right? To check whether f is continuous at point A or not, right? So first we have to check that whether, right, 0, right, which also 0 is also 0. Okay. And then the second we have to find the limit x close to 0, right? This we have not that way, right? Can you remember, right? We have to find from the definition of the absolute if x greater than 0, right? And absolute x equals negative x when x less than. That means that we have to find the limit from the left and from the right hand side. Okay, then we find first, right, the limit from the left hand side, right? This means that, right, the value of x less than 0, right? So if you cannot remember, right, just use the number round, right, to see from the left or from the right, right? So from the left hand side, x less than 0. Okay, so you choose the below functions, right? So this is the limit of the negative x which equals 0. The same of the limit from the right hand side. So x close to 0 from the right hand side, the value of the x is positive. So you choose write the above functions, which also 0. So both are equals. Then we can conclude that this limit 0 is also equal to the value of the the functions, right? So f is continuous at point x equals 0. Okay. Well, we can find the limit, right, for any intervals. Okay, so before we finish, we have more theorem. So if you have that the f and g are continuous, we can conclude that, right, the sum of the function, difference of functions, the constant term times the functions, the products of the functions, and the quotient of the functions, right, all functions are also continuous. Okay. And any polynomial or rational functions also continuous on the domain, right, of x2, right? And then every number, right, in that domain, polynomials, rational functions, root functions, and radical functions, right, or the quotient function also continuous. If I would like to say that the intervals, okay, so if we would like to find that f is continuous on open interval, right, from a to b, right? So this means that you find, right, the value of x greater than a and less than b, right? So you just find by let c is in the open interval, right? And check that whether the value of the fc equals the limit when x close to c of these functions. Okay. So this is the definitions, right, to find the limit on the open interval. How about the closed interval? Right? You have to check more, right? 3 conditions, right? First one, check whether f is continuous on open interval, right? And the second case, check whether f is continuous. Okay, so we have the number right and the open interval, right, from a to b. Okay, so this we have. That means that we have to find the limit, right, close to a from the left hand side, right, and close to b from the right. Oh, sorry, close to b from the, this is close to b from the left hand side, right, and close to a from the right hand side. Okay, right. So that is that we have to check whether f is continuous, right, from the right hand side, right. At x equal a, and then check whether f is continuous from the left at x equal b. Okay, what does this mean? That first, right, you just check that any point C, right, in the interval, open interval from A to B, right, that the value of the C equal the limit. And to check the continuous from the right, that means that you have to check that the FA, right, equal limit from the right, that means right x close to A from the right hand side of fx, right, and check at the point B, right, the limit x close to B from the left hand side. I mean, right, you have to check 3 conditions, right, to check whether f is continuous on closed interval from A to B or not. Okay, so let's see the examples. Okay, in your note, right, you have okay, if I suppose that, right, I have so let's see the easy one. If we define fx equals x plus 2 when x greater than 2 and x squared when x less than 2. So check whether f is continuous at x equal to or not. So what is the f2 in these problems, right? They're not defined, right? So we can see that, right? f2 is not defined, right? So that means that, right? So since f2 is not defined, so we got that, right? So f2 does not exist. So no need to find the limit, right? When one condition is not exist, right? We can conclude that f is not continuous, right? Or discontinuous, right? F is discontinuous or not continuous. At this point, x equal to k. This or not k. So no need to find the limit, right? If one condition is not exist, right? So we can conclude that this is continuous, right, or not continuous. Okay. So let's see more. Okay, so the case that exists, x equal x plus 6 if x greater than or equal 3 and equal x squared if x less than 3. First we have to find, right? So this term you find at the term when the point x equal 3. First we find the first case, right? f3 exists or not, right? So you got 3. This is the exists. And then the second case we find the limit when x close to 3 or x approaches 3, right? But 3 you separate like this. So you have to find the limit from the left and the limit from the right. So the limit from the left hand side that you consider, right? The below function that when x less than 3, so you press at this term, right? And so find the limit from the right hand side, right? You have to find when x greater than 3, right? So we choose the above function. So you also got 9, right? So both are equals, right? Then we can conclude that this is equal 3 and equal to the value of this point, right? Okay, then, right, so we can conclude that, right? So f is continuous, right, at the when x equal to 3. Okay, so let me see more in more detail, right? In the classroom, for the quiz, it's just the conclusions, right? Some points that the important points, right, that we would like to find. Okay, so we will see it again next clip, right, on the next chapter. Bye.